and say this again. So we're going to do practice problems. We have these three basic ones, and then we'll go to the one we started yesterday. If you want to skip some space, yes.
What is STP?
Oh, that's a good question. STP from the reading that all of you did means
Standard something pressure.
standard temperature and pressure. So you might want to add this to your notes. It's not that hard, but STP equals standard pressure and temperature. So standard temperature is room temperature, which is 25 degrees Celsius, or 298 K, which I would memorize it as 298. That's what we consider room temperature, which is 72 degrees as well. That was correct. We don't use Fahrenheit in chemistry. All right, any guesses what standard pressure is? 1.
What? No way.
Okay, so you'll see that a lot. It'll say certain gas under STP, yada, yada, yada. Easy enough. So STP means standard temp and pressure. Okay, so here's our 3 easy practice problems. Ready, set, go.
What is this? Merkel.
You had 2.
No, Erica had one, and she shoved the wrapper in my backpack.
Smart kid.
She told me about how you called her out today in first hour or something.
Kind of. Well, I had a question that no one knew the answer to, and I said, all you kids with candy bars, you should answer this question. But
Nobody did.
yeah, no one did. I dropped this, and now it's like this, and that's super annoying. But I don't want to put tape because then it'll be annoying.
I don't know what to tell you.
All right. Take about 5 minutes.
Yeah, why don't we stop it?
I stopped because if we're going to practice problems for 5 minutes, then you just record me talking stupid crap. Then it's fun. All right. Well, anyway, Keely's watching live, so we're good. All right. PV equals NRT. So what's T equal to?
PV divided by NR.
Okay, I'm going to warn you that a ton of you do algebra the wrong way. So I would always do it the way I do it. I would write down PV equals NRT, and then I would do it. Don't be dumb and be like, okay, well, I know I need T, so T equals PV R and T or something like that. Like, don't pervert. Whoops. Anyway, I've recorded that. But like, I'm just telling you, don't try and do algebra in your head. There's plenty of chemistry screwing up your brains. Don't let basic algebra do it. So T is PV over NR, right? So let's just plug it in. Does it say STP?
No,
Nope. So what's the pressure?
that one. Oh, that's why that-
1.95 atmospheres. Sorry, I cut that off. What's the volume? What's N? And what's R? And I end up with some number, probably big.
Yeah, it's like 4.4.
That one?
4.4? I got 4.46.
That's what I wrote.
4.46. Wait, 7.
Oh, you're using an Apple calculator, that's why.
No, I use an Apple.
I would not use an Apple calculator ever, but it's not Apple's fault, it's your fault. Calculators never screw up.
It's just easier to play that.
Okay.
Let me guess, you have an Android?
Okay, how do we feel about these? Okay. Yesterday, most of you gave me 5 fingers and said, I think we're all right. Just protesting, not going to answer, Blaine.
Does he ever answer?
No. And Brown, she usually just raises her eyes like, I think it's very nice, yes, but
It's like,
anyway, moving on. Okay, so let's make it more complicated. Let's include chemistry.
oh, I thought you said this could be easy.
already doing chemistry.
No, that was math.
Can we go over the problem that we started yesterday?
That's what's coming right now. Right here.
We did pick it
Okay.
quizzes in math yesterday and I wanted
You're
to
welcome.
try.
All right. You can complain about it, or you can just realize it's not that bad. Okay, listen. In PVNRT, it's math, but there's a variable in there that makes it 100% chemistry. What variable makes it chemistry? The moles. The moles. Good. Front row. Thank you. The moles. There's like a million ways to get moles. We've done a lot of them, right? We have another one called PVNRT. Now, we have a way to make gases from solids, make gases from other reactions with gases, and we can keep track of those moles and do all that we need to do. But the N value, that's all this chemistry is required to find N, and then we just PVNRT it. Okay, I'll come back to this problem in a minute, but we're going to follow this pattern right here. We're going to balance the reaction. We're going to mollify everything. We're going to take the limiting reactant moles and determine how many wanted moles are available. And then finally, we'd be ready to do the math. The wanted moles will always be the N value. Okay, so then we're off to the races. And it won't be bad because we've done this like 4 times already. It's easier the 4th time than the 1st time usually. All right. All right. So it says what volume of gas will be produced when yada, yada, yada. So the first thing we got to do is balance this reaction, right? It's been a long time. I noticed on your test when we came to do the math part there that a lot of you were fine at the math and not good at balancing. It kind of depressed me a little. But if there's 2 NAs right here, how many must there be here? 2. That means there's also now 2 CLs, which means I got to put what here? A 2. That means there's how many H's now? 2, and there are 2 H's, so that's good. All right, let's come back. We have 3 O's, and I have 1, 2, 3 O's, so that's a good sign. 1 carbon and 1 carbon. So it's 1, 2, 2, 1, 1. How do we feel about that? All right, that was fun for me. You missed this stuff, huh? Yeah, I knew you did. Okay, I have 25 grams of this, and I have 200 milliliters. I'm going to say 0.2 liters of 3 moles per liter HCl. Sound familiar? Oh man, all you people used to like love and appreciate me. Now you're like, screw this. We are not doing this again. Well, yeah, we are. Well, I don't know if you are, but I am. Okay. So what we need to do, this is the nice, that was a total speech impediment here. The nice thing about PVNRT is I don't give a crap how much of this and this there is because I only care about the gas. Well, finally, some positivity in the room. Thank you. It makes it easier. Yeah, that's right. So here we go. The first thing I need to do is convert it to moles or mollify. I don't use that word very often. I just made it up. So you do like it? Mollify. Okay, this one's easy because molar means moles per liter and the volume is liter. So I just take 0.2 and multiply it by 3. So I get 0.6 moles of HCl. Okay, how do I find the moles of sodium carbonate? Okay, I divide this by its molar mass. 106 sounds good to me. Uh-oh, someone else. Okay. I would love to, Tim. Thanks for asking so genuinely. It's okay. Here we go. There are 2 NAs in this substance, plus 1 C, whoops, whatever, plus 3 O's. He wanted to know how to find that number. He doesn't remember. So I have 2 times the mass of sodium, which was 23. You see it? It's the big number. Got you. Plus 1 times 12, plus 3 times 16. 48, yeah, 106. No, 106. Okay. Now, when you calculate this, you may remember this is per 1 mole. So, hey, there's moles. I know I can use that to find moles if I have that ratio. So I have 25 grams over 106. That's going to be equal to 0.22, 0.236. Okay, my friends. Now, we've asked this question a lot, but it was a long time ago. People have always gotten lost on this step. So focus with me. These are my 2 molar values. I need to determine which one's the limiting reactant. So look, we've done this a lot. I find the one with the bigger coefficient. This is a 2. And I ask myself, is 0.6 at least 2 times more than 0.236? Yes. If the answer is yes, then this was your limiting reactant. Does that sound familiar? Okay, now it's really not bad from here. Are we ready? What number is in front of Na2CO3? A 1. What number is in front of CO2? A 1. So the N is equal to this number. .236 moles. It's like 3-4 weeks, sometimes 5. It depends on how much you complain. Yes. Yeah, if there are numbers, then you just either multiply it by 2 or divide by. You just set it up like a picket fence. You'd have a. We would have a 1 here and a 1 here, but if this was a 2, we'd have a 2 here and a 1 there. Like you just take the coefficients, take your given, and you're set. All right, are you with me? Once we have N, then the rest was not that bad, right? So what volume? PV equals nRT. So volume is nRT over P. You have N, you have R, you have T, you have P. All that stuff, I had to use it to find the amount of moles. And can you apologize? It wasn't the worst thing we've done all year. I got some serious attitude on that. All right, you calculate that. I think I know why I have a huge headache. How are we doing? Well, I'm not saying to stop and cease existing. I'm just asking how you're doing. All right, how we doing? This, the ones up front said 6.05, is that? Someone's stoked.
6.047. They're wrong.
Okay,
What was it said?
What? I got 6.05.
okay, 6.0 and then a number that you feel like writing down. Give me a thumbs up. Are we all right with this? Okay. Now, Danny asked, is it all right if I call you Danny? All right. She said, well, what if they're not the same numbers? And I kind of brushed through it, but maybe I should explain that more because the next one probably won't be. All right, Davis, you predicted this moment would happen. I will miss you. Pass that diagonally. Imagine. Okay. So this is not awful. If they're not the same number, let's say this was a 3, then you would just multiply it by 3. If it's like a 2 and a 3, just set it up. If when in doubt, set up a picket fence. We had 0.236 moles of, I'm just going to call this A to save space. So I'd have a 2 mole A, and then whatever the 3 moles CO2. You just take the coefficient you don't want on bottom, the coefficient you do want on top, and then just do the math. That sounds familiar? We've done it a lot. Okay, I think this is the same one. No, it's different. Same chemistry, same chemistry. So there's something way different at the end. Bensons have no idea what to do right there, right? I think they were late. What do you do with Tor? You divide it by 760. Okay, give this your best shot. Is it 23 grams before as well? I'm getting soft.
No, this is 25 grams.
Okay, perfect. It's so different now. Okay, so try and do this on your own. And we're just gonna have some awkward silence on the YouTube video. I refuse to pause. All right, who needs more time? It'll take you all day. Oh man. Oh, noob. You know, you can divide by 2 just to fix that. Okay. All right, how are we doing? I think we have a problem.
Why is Celsius a thing? Can we just use Kelvin only?
Oh, you fell for that? Unreal. What kind of children have I raised? All right, here we go. We ready? Okay, here we go. I'll give anyone a ride home that needs one, but it will be after the basketball game. So you might have to wait a while. All right, my good friends, are you okay that it's the same balanced reaction? So I'm not going to rewrite it. Let's go straight to the molification process. That sounds even cooler. All right, here we go. 23 grams of sodium carbonate. So 23 divided by 106 is 0.19, 0.20 something. 217. Okay. You with me? All right, then the acid, this time it's 0.025 liters times 3, right? Right? So I get 0.075 moles. Okay, everyone's talking, but I just need to feel validated. I could stand up and then you'd probably listen better, but I don't feel like it. All right, I'm gonna put a 1 right here and a 2 right here. Do you know what those were for? That was the balanced, right? So I'll bring them down a 1 and a 2. So I ask myself, I always go to the bigger one, is 0.075 at least 2 times bigger than 0.217? And it's not, correct? Okay, so this time HCl is your limiting reactant. Okay, right? Now looking here, HCl is a 2, and this, I left it as a 3, but remember, it was actually a 1. It's a 1, right? So just listen with me. We create 1/2 as much CO2 as we have HCl. Right? Okay. All right. It was a laugh of, why did I take this class? And we're like 6 months in, so tears follow. Oh, never mind. All right, so N is equal to 1/2 of this, which is 0.0375. Thumbs up. Okay, Then you just plug in, and in the PVNRT, we're solving for volume again. I know this is repetition, but I always will do this. PV equals NRT. This is the only way Tom Davidson doesn't screw up algebra, because I'm super good at doing algebra the wrong way. So my volume must be equal to NRT over P, correct? Okay. So then I just plug it in. 0.0375 R, 0.0821. T was this number plus 273. That's 300. And then divide it by whatever this ended up to be. What was that? And what do we end up with? 0.9 something? All right. Doable? Okay. Are we ready? Okay. So, yes. Okay, good question. I figured I'd probably forget something. What do you want it to be? 17's too high. What? 1. What a good call right there. 1 molar. Okay. Did I skip anything else? I'm really good at these problems of leaving something out because there's a lot you got to put in. Okay, we ready? Fire away. Okay, if you need help on just like the equation is this. That's the chemistry in case you screwed that part up. How many people screwed it up? Raise your hands. Oh. Oh. Is it because you forgot magnesium was a 2? How many forgot hydrogen was diatomic? How many did both? You what, Seth? It's a +2. +2. Nothing happened. I balanced the equation for those that didn't have it balanced. What? It is. We're actually going to do this lab tomorrow.
Tomorrow? As in Wednesday? It's been a day. Okay, so
Okay, who needs more time still? Raise your hands. Okay, I'll give you about 1 more minute is all. All right, I'll move it on. Here we go. So I wrote out the first step was to balance the equation, like depression level 10. Some of you will fail this problem at that step. Balancing. Okay, the next step, please don't talk. The next step was to convert to moles. Did I do it wrong? Okay, so now I have moles. I have 0.416 moles of Mg, 0.2 moles of HCl. So remember, I asked myself the following. I find the bigger coefficient and I say, is 0.2 twice as much as 0.416? And the answer is no. So which one's my limiting reactant? The HCl is. So my 0.2 moles, I'll do this in case you're still lost here, of HCl. I want to know moles of H2, correct? So I need moles HCl, and that's this number. I need moles, I didn't write that, and that's this number. So it's really, I have 0.1 moles of gas, and then I just plug it in. PV equals nRT. Volume is nRT over P. You're probably sick of this. N, I just found, was 0.1. R, 0.0821. T, I don't remember. 305, because I took 32 and added 27, or sorry, 273. And the pressure was 0.992. And what do I end up with? What am I doing? Is that the right answer?
Yes.
Thank you. Thank you. Thank you. Like, I feel so validated right now. I've never felt better about myself in my life. All right, I would like you to do the following problem for homework, like a practice problem tonight. I haven't, I gotta write it. I thought I had one more, but I do not. Okay, Alyssa, favorite acid? HCl, because we've done it a million times. All right, someone give me a red flag compound.
I don't.
What? It has to be SO3, sulfite. What would it make? I'll just start with the easy one. It makes KCl, right? And this one's not as stinky, but it is stinky, but it's not the one that will kill you stinky. Hydrogen sulfide. Okay, so here's the equation. Whether it's balanced or not is up to you. You have to balance it, but this is what I'm going to tell you. Give me your favorite number between 1 and 500. 76 milliliters of 1, 2, 3, 4, or 5. Of 5 molar. You guys you're making this so much harder on yourself.
One for all of them.
Yep.
You want to do 0.001 liters?
100 grams of 100 grams of K2SO3. Nope. Nope, it's done. 76 milliliters of hydrochloric acid. All right. I want to know. Ooh, I want to know. Let's switch it up. Let's make this crazy. I want to know the pressure. This reaction took place in a 500 milliliter rigid container. So we know the volume is 0.5 liters. We'll say the temperature that it happened at was 300 Kelvin. Have I missed anything else? Then type it in your calculator. All right. You're solving for ATM. Am I missing anything? Okay, there you go. What? Yeah, everything would stop. So there'd be no pressure, which would mean no volume, which the world implodes. Okay, give this a try. No. I've seen it.